Have you ever considered how nature tends to organize itself in patterns so that it can function effectively? Every single one of these patterns has a purpose in nature and is fascinating to observe. Nothing in nature happens for no reason. Furthermore, keep watching this video and look at examples of some of the ones we were able to spot. And the next time you go for a stroll, you might be able to detect some of these patterns. You might already see spiral, fractals, foam, cracks, spots and stripes, symmetries, waves, tessellation, meanders, and others. The first pattern is a reflection symmetry. As you can see, we were able to capture and film a natural and man-made symmetry reflection in which one half of an object mirrors the other. In addition, the first image corresponds to a butterfly plant, and the following one is a metal gate. The preceding pattern is known as rotational symmetry. You can notice both nature and man-made symmetry in the photographs and video, which signifies the number of different orientations in which an object appears exactly the same for each rotation. The first image is a flower, and the second one is an umbrella. The following pattern is a translation symmetry. It demonstrates how symmetry in an object can change positions while maintaining the same orientation in both forward and backward motion. Also, the first image is an ant's step, and the second one is a person's regular footstep. The next pattern is a spiral one. A spiral is a curve which emanates from a point, moving farther away as it revolves around the point. So, you can see a picture and a video of a snail and bread on the screen. The preceding pattern is a meander. You can see a meandering pattern seen in nature and man-made where curved lines are the dominant design. The first image is a helical growth that's seen in a plant, and the second one is a cement design. The following pattern is a wave. Waves are yet another common pattern found in nature. Think about it. Waves can be seen in the water and at the snap of a rope. Cracks is one of the patterns. Cracks are overlooked because they are so common. It is often the pattern engineers want to avoid. For example, a crack in a trunk of a tree and a crack in a road. Tessellation is one of the patterns. A tessellation is created when a shape is repeated over and over again, covering a plane without any gaps or overlaps. Additionally, the first image shown is a pineapple, which is a nature one, and then a Rubik's Cube, which is a man-made one. The next pattern is bubbles and foams. These are patterns in nature that are formed from repeating spheres. Foams are volume of bubbles of many sizes, where the spaces between each larger bubble contain smaller bubbles. In some ways, foams can be fractal. Some foam patterns are uniform in composition so that all the bubbles are relatively the same size. In addition, the first image shows a natural bubbles, while the second one is a man-made bubbles. The preceding pattern is spots. In mathematics, stripes turn into spots when the pattern of parallel waves become unstable. Furthermore, the first photo shows spots in a trunk of a tree, and the next one is spots in a dress. Stripes is the next pattern. Stripes are made by series of bands or strips, often of the same width and color along the length. Moreover, the first photo shows a striped plant, and the second one is a striped dress. The following pattern is a fractal. A fractal is a kind of pattern that we observe often in nature and in art. As Ben Weiss explains, whenever you observe a series of patterns repeating over and over again at many different scales and where any small part resembles the whole, that's a fractal. Additionally, the first image shown is a plant, and the next one is a flower. Affine transformations is the next pattern. It is a linear mapping method that preserves points, straight lines, and planes. The processes involved in affine transformations are rotation, reflection, and scaling. Furthermore, the first image shown is a plant, and the next one is a money bouquet.